Today we're going to talk about conditional probability, section S7J. To start off with, we had this warm-up. In IB, they're going to expect that students know how to convert from decimal notation from scientific notation to decimal notation and vice versa. Also, when you have a calculator, you're going to see notation like this on the calculator that might be like 4.5 E07. And if you wrote something like that on the IB exam, they would not accept it. So you need to recognize that this means the E07, the calculator is not able to mark it as 10 to the 7th power, and that's what this means. Or if you were writing it out in regular notation, you would have 6 zeros. You'd move the decimal place 7 places. So anyways, hit pause if you need more help on this. Okay, so the next thing we're going to talk about is conditional probability. So conditional probability is when there's a condition. Let's look at the first example, and then we can talk about it some more. Okay, you've got two circles of students. This box represents all the 25 students. 14 of them like pizza, and 16 of them like iced coffee, and one student doesn't like either, so that student's out here outside of the classroom. Okay, and 6 of them like both, so I'm going to put the 6 there because we have 6 students like both. Okay, 14 like pizza, so this value here is going to be 8, and why is it 8, you ask? Because these two have to add up to 14. Okay, 16 like coffee. If that's 6, then this has to be 10. Okay, now that we have the Venn diagram filled out, let's solve question 8. What's the probability that a person likes pizza? And when we did this in class, just about every person got this right. The number of pizza-liking people is 8 plus 6, which is 14 out of 25 students. Okay, pretty much everybody got this one right in class. Now the next one, what's the probability that a person likes pizza given they like iced coffee? Another way to write it using this notation here is P for pizza, this line here, and then C for coffee. Okay, so this line here means given the second thing. Now, since we're talking about who likes pizza given that we like iced coffee, the first thing that I'm going to do is I'm just going to pretend that all of this doesn't exist. Okay, our world only deals with coffee-loving people. So how many people love coffee? 6 plus 10, so my denominator is going to be 16. Okay, and then how many of these 16 people like pizza? So there's 6 people that are pizza-loving coffee drinkers. Okay, so given that a person drinks coffee, that means our denominator is going to be 16 because we're only looking at a world of coffee-drinking people. Hit pause and re-listen to this if you need extra help on this. Okay, next one. Okay, we've got a class of 40 students. 34 like bananas, 22 like pineapple, 2 people dislike both. Okay, so we're going to draw our Venn diagram. And 40 students, 2 dislike both. So we have 2 students here that don't like fruit at all. What's wrong with them? Just kidding. Okay, 34 of them like bananas, 22 like pineapples, and we got 40 students. So we don't know, okay, this is bananas, P for pineapple. Everything in this banana circle has to add up to 34. Everything in the pineapple circle has to add up to 22. I'm not sure what numbers to put there, so I'm just calling this A, B, and C. So if 2 students don't like fruit, then these 3 regions have to add up to 38. Because together, these 3 regions plus the 2 here is going to add up to 40. Okay, now we know that 34 like bananas, so region A plus B equals 34. Okay. So this is going to be 34. And now what I'm going to notice is, okay, well, we know that A plus B plus C is 34. I'm sorry, it's 38. So I'm going to do a substitution, and I'm going to replace A plus B with 34. So now I've got 34 plus C equals 38. I'm just rewriting this equation here, and I'm substituting A plus B with 34. Now I can solve for C. If I subtract 34 on both sides, C is equal to 4. And I'm just going to write 4 right there, right now. Okay, now that I have C, I can solve for another equation. We know our pineapple-loving people, there's 22 of them. So this region here has to add up to 22. So I can say B plus C equals 22. Now I already know that C is 4, don't I? So I'm going to replace C with 4. So now I've got B plus 4 equals 22. And now that I know that that's 4, I can say B equals 18. So I'm going to write 18 here. Okay. And now our last step is to find A. So we know that A plus B equals 34, because this is the region of the banana-loving people, right? So, and then we just found out that B was 18, so I could say A plus 18 equals 34, and now I could subtract 18 on both sides, and I know that A equals 16. Okay, now that I have my Venn diagram correctly filled out, now I can start solving for these questions. So, the first question says, what's the probability that, okay, this was highlighted like this, right? Okay, so what's the probability that the person likes both? Okay, so there's 40 students, so my denominator is going to be 40, and likes both is going to be this section in B, because these people only like bananas, these people here only like pineapples, this region here overlaps, they like both. Okay, probability that the person likes at least one of the fruits. So 16 plus 18 plus 4 is going to give me this numerator. Okay. And then this one here, the probability that the person likes bananas given that they like pineapples. So like we did in the other example, we're going to only look at the pineapple world. So you can see I'm covering up the banana world over here with a piece of paper. It doesn't exist. So my pineapple-loving people, there's 18 plus 4, which is 22. And the banana-loving pineapple people is 18. You may want to hit pause and think about that for a second. Okay, let's do question D. What is the probability that a person does not like pineapple given that they like bananas? So now I'm going over here. Given that they like bananas, here's our banana circle. So my world only consists of banana-loving people, which is 16 plus 18. My denominator is 34. Right? And my numerator is 16 because these people don't like pineapples, so clearly it's just these group here. And if it said loves pineapple, then we would have had 18 in the top. You may want to hit pause and think about that. Okay, the next problem is solved the same way, where we had 3 variables. The group of 50 students, 40 take math, 32 take physics, and every student takes at least one. So we know that there's nobody out here that's skipping math and physics, fortunately. So this region A plus B plus C adds up to 50. 40 people take math, so A plus B is 40. 32 like physics, so B plus C is 32. And then I'm going to do a substitution. I'm going to replace A plus B with 40. So here I've substituted in this equation here, I've replaced A plus B with 40, and then I subtract 40 on both sides, I get C equals 10, and then I put it there. And then the next thing I say, okay, so I know that C is 10, so I'm going to use this equation here and replace the C with 10, and then I can subtract 10 on both sides. I get B is 22, and then I'm going to take the second equation, A plus B equals 40. And with this equation, A plus B equals 40, I'm going to replace B with 22. Okay, and now I can just get the A is 18. Okay, now that I've got my Venn diagram, I can start answering these questions. The probability that a student studies math but not physics. Okay, so we got 50 students total, and studies math but not physics, so it's going to be this outside region is not physics studying. So 18 over 50. Okay, it's okay if you don't simplify the fraction. That as long as you understand the idea, that's fine. Question II. Studies physics given that he or she studies mathematics. So what I'm going to do is I'm going to focus on this math circle, and so right here you can see I just crossed out everything else. My world is only full of math-loving people. Okay, so my denominator is going to be 18 plus 22, which gives me 40, and my numerator was the probability that they study physics, and that numerator is going to be 22. You may want to hit pause and think about this. Okay, next, I'm going to rewrite this one out. Okay, so you've got a top shelf of a cupboard and a bottom shelf on the cupboard. So, so the top shelf and the bottom shelf. Okay, and on the cupboard we've got pumpkin and we've got chicken soup. Okay, we've got pumpkin, we've got chicken. Okay, so the first thing I'm going to look at is Luca is twice as likely to get a can from the bottom shelf as he is from the top shelf. So if he's twice as likely, then I'm going to write 2 out of 3. And so this is going to be 1 out of 3. Okay. If he said he was equally likely, I would have written a half and a half. If he said there was a quarter chance of being on the top, then I would have written 1/4, and here I would have written 3/4. Remember, these fractions always add up to 1. Okay, so now we've figured out what shelf we're going to pick from. Okay, so if it's the top shelf, there's 3 cans of pumpkin and 2 cans of chicken. So 3 over 5 and 2 over 5. Okay, next. The bottom shelf contains 4 cans of pumpkin and 1 can of chicken. So 4/5 and 1/5. Okay, so now let's answer the first question. What's the probability that the person likes chicken? Okay, so if a person likes chicken, they either get it from the top shelf, which is 1/3 times 3/5. And so this is the probability of top shelf. Oh my goodness, I got this mixed up. Let's just use a totally different color. Chicken, right? Okay, so 1/3 times 2/5. Okay, is my top shelf chicken loving people. And 2/3 times 1/5 is my bottom chicken loving people. And if I have my top shelf chicken and my bottom shelf chicken, that's going to give me, together, is going to add up to the chicken probability of getting chicken. So this is 2/15, this is 2/15, together adds up to 4/15. Okay, so that's the answer for question A. Now question B says, what's the probability that it's taken from the top shelf given that you like chicken? So the top shelf given that it's chicken. So my denominator has to be the probability that we like chicken. So, and I already figured that out, that's 4/15. Okay, so this is the probability that we are having chicken. Okay, now the numerator is going to be the probability that it's top shelf given that and chicken. So top shelf and chicken is this route here, right? So 1/3 times 2/5 or 15ths. Sorry, 1/3 times 2/5, and that's going to give me 2/15. And so you might want to think of it this way. This is the probability of top, the intersection of top and chicken, and my denominator is the probability of chicken. Okay, so once again, this here is the probability of the intersection of top shelf and chicken, and my denominator is the probability of chicken. And this formula here is on the top of the previous page. Okay, the intersection of A and B divided by the probability of B. So in this case, B is chicken, and in the numerator, it's the probability of top shelf intersection with chicken. All right, so now let's simplify this fraction. 2/15 divided by 4/15. Since the denominators are the same, we can simplify that to 2/4, which simplifies to 1/2. Okay, number 5. Lots and lots of people had trouble with this in class, so we need to talk about number 5. Okay, so first thing I'm going to do, I'm going to draw 3 circles. Okay, and the very first thing I'm going to do is I'm going to notice that 2% read all 3 papers. So this is paper A, paper B, paper C. 2%. I'm going to write 2% here. Now, I'm going backwards in here. So 4% read B and C. So that means this region right here has to be 4%. So I'm going to have to write 2% here because these two have to add up to 4%. Okay. Then let's look at another one. 5% read A and C. So A and C. So this is going to have to be 3% because these two have to add up to 5, and so on. And then 8% read A and B. So this is going to have to be 6% because these two have to add up to 8%. Okay, so now I can see that 14% read C. So that means this whole circle has to add up to 14%. So I can do 3 plus 2 plus 2, and that's going to give me 7. And so 14% read C, so this is going to have to be 7% because these 4 values have to add up to 14%. You do the same thing with the B and the A, and you're going to get 9% and 6%. Okay, so now we're ready to start solving the problem. Okay, so these are all the percents here. Question A says, what's the probability that that there's a person doesn't read the paper or a magazine? So first I have to add up all of these. So we can say 9 plus 6 plus 6 plus 3 plus 2 plus 2 plus 7. If I add all 7 of those together, I'm going to get 35. So that means 35% read all of those. So how am I going to figure out who doesn't? I could do 100% minus 35, and then we're going to get 65. So there's going to be 65 out of 100, or you could just write, you could simplify this as a fraction as 13 over 20, or you could just write it as 65%. All of these answers are just fine. Okay, question B. At least one of these papers. So I'm going to add all of these together to get at least one. So at least one is going to be, if I add all these together, we know that's going to be 35 over 100, or 35%. Okay. C. Exactly one paper. So exactly one is going to be 9 plus 6 plus 7. So 9% plus 6% plus 7% is going to give me 22%. Okay. D. Either A or B. So that means A or B. So it could be, so I'm everything in here, not including this out here. So A or B. If it's A or B, then that could also be written as the union. Okay, so let's add them together. 9% plus 6% plus 6% plus 3% plus 2% plus 2%, and that's going to add up to 28%. Okay, let's do question E. You may want to hit pause if you need to think about it. So, probability of E is A given at least 1. Okay, so at least 1, we've got our denominator is 35 from the problem B here. And the probability of A, given it's at least 1, is going, our numerator is going to be 9 plus 6 plus 3 plus 2. Which is equal to 20 over 35. And you could write that as a percentage if you wish. And then question F is the probability of C given A or B or both. Okay, so A or B or both is going to be A or B or both. It's going to be 9 and 6 and 6 and 3 and 2 and 2 is my denominator. So those percentages, so 9, 6, 6, 3, 2, 2, that's A or B or both. And being in C is the 3, 2, and 2. And that gives me 7 over 28, or 1/4. As I said, you may want to hit pause and think about this some more. Okay. Here we go. Let's do this one now. Okay. So we've got an urn here, and you're going to flip a coin to decide which one. So A and B, half and half. It's 50-50 chance. And you're going to get red or blue, 2/5, 3/5, red, blue. Okay, so determine the probability that it's red. So it's either going to be A in red or B in red. So this is going to be equal to 1/2 times 2/5 plus 1/2 times 4/5. Okay. And that's the probability that it's red. So I've got 2 over 10 plus 4 over 10, which is going to give me 6 over 10. Okay. So let's just say that's the probability that it's red is 6 over 10. Okay. Now question B says, what's the probability, given that it's red, what's the probability that it came from B? So given red. So this can be interpreted as the probability of the intersection of urn B and red divided by the probability that it's red. Okay, so the probability that it's red, we just determined, is 6 over 10. And the probability that it's blue and red, or sorry, urn B and red is this route right here, right? Oops. So urn B and red is going to be 1/2 times 4/5. So that's going to leave me as 4/10/6/10. And that simplifies to 4/6. Or you could just write 2/3. Either of those answers are correct. Okay, let's do our last question. Okay, so a group of teenagers are surveyed, and here are the results. A for arcade games, S for sports, R for role-playing. Find the probability that a person random does these things. So if you add all of these together, 7, 13, 18, 5, 9, 16, 22, and 5, that adds up to 95. My denominator is 95. Okay, so the first question, plays arcade games but not role-playing games. So arcade games but not role-playing games. So that's going to be 7 and 13 play arcade games but don't like role-playing games. So we have to exclude the 5 and the 9. Okay, probability that a person does sports and arcade games. So, okay, so the word "and" means it's going to be intersection. So we could write this as S and A, because it's the intersection. And so the intersection of S and A is 13 and 19. Okay. Oh, sorry, 13 and 9. I didn't mean 19. Okay, next one. The probability that it's role-playing or sports games is going to give me anything from role-playing, 5, 9, 16, 22, and anything from sports, we also have to add the 13 and 18. And that's how we get this. D, sports games given that he or she plays arcade games. So my denominator has to be the arcade game people, which is 7, 13, 5, and 9. 7, 13, 5, and 9, which is my denominator. And sports playing people that like arcade games is 5 and 9. I'm sorry, sports playing, 13 and 9. Okay, the probability that it's a role-playing game given that he plays arcades. So once again, my denominator is 7, 13, 5, and 9, because that's all the arcade game people. And the probability that they're role-playing is 5 and 9, which is going to be 14. Okay, last question, F. The probability that that a person does arcade games given that they don't play sports. So here, given that they don't play sports. So here's the sports circle. So anything outside of there is 7, 5, 22, and 5. So my denominator is all the non-sports playing people, 7, 5, 22, and 5. And you can see that I have that here. Okay, so, and I've written a little prime here to indicate not playing sports. Now the probability that they play arcade games is, from our picture, 7 and 5 are the arcade game playing people that don't play sports. Okay, you may want to hit pause and play this again for extra help.